Okay, today we're going to work on solving inequalities. Remember, an inequality is sort of like an equation, but instead of an equal sign, like that, you have, a less than sign or a greater than sign or a less than or equal to or a greater than or equal to sign. These are the different types of symbols that you'll typically see in an inequality. And it pretty much just means instead of something being equal to something, you're just saying something is less than or greater than that quantity. Okay, so let's just go right on in and look at how we can start to solve some of these inequalities. Let's say we have x plus 2 is greater than 5. Now, normally we see equal signs here, so that means this is equal to this. In this case, what I'm saying here in the equation is whatever x is, or whatever set of numbers x is, when I add 2 to it, it's going to always be greater than 5. Okay, so let's go ahead and solve for what x actually could be. We're going to do it the same way we do equations. We need to get x by itself, so we're going to simply subtract 2 from both sides of this inequality, and then we're going to get x by ourselves. So let's do that. On the left, we're going to have x, and then I'm going to subtract 2 from both sides. On the left, x, 2 minus 2 is 0, so it's going to go away. I'm going to keep the greater than sign is greater than 5 and minus 2. Here all I've done is subtract 2 from both sides. On the left it went away, the 2 went away because 2 minus 2 is 0, and on the right I have this. So that means that x is greater and 5 minus 2 is 3. Now notice that x is not equal to a number. X is a set of numbers. X, in this case, the values of x that satisfy this equation are all values of x greater than 3. So that means the numbers that satisfy this inequality are numbers like 4, 5, 6, 7, all the way up to infinity. Notice 3 is not included in this set because it's a greater than. X is greater than 3. It's not equal to 3 because we don't have a bar under here that says equal to. So these are the set of numbers that satisfy this original inequality. And you can show that on your number line. Remember from the very first video we talked about the number line. So here's a number line. Here's 0, 1, 2, 3, 4, 5, etc. and it goes off to infinity. Well, if x is greater than 3, I'm going to put an open circle here because we are not including 3, and so x is greater than 3 is simply going to be all the values. I can't seem to get this to write correctly. All the values out here off to positive infinity. So from 3 greater than. So that's how you graph that. Now in numbers it's 4, 5, 6, 7, 8, etc., etc., etc. But that's how you graph it. Okay? So that was a fairly simple inequality, and none of them are really hard. If you know how to solve equations, you're going to basically be able to solve these inequalities. And there'll be a few things along the way that we'll deal with. Let's say we have negative x, like this, minus 3 is less than or equal to 7. Let's just say. Okay. Now this is going to be just like an equation. I want to isolate x by itself. So how am I going to do that? First I'm going to get rid of this 3 and I'm going to move it over here. In order to do that I'm going to add 3 to both sides. So I'm going to be left with negative x less than or equal to 7 plus 3. On the left I've added 3 and the 3's went away. On the right I've got 7 plus 3 and this is equal to 10. So I'm going to have negative x is less than or equal to 10. Now that's pretty darn good, but I want x by itself. So in order to get x by itself, I need to divide by negative 1 because this is really a negative 1 times x, so I can divide by negative 1 and that'll get rid of the negatives, and I can divide by negative 1 here. Now here is the thing to keep in mind during this lesson. This is the most important thing. When you divide or multiply, see, adding or subtracting numbers across inequalities, no problem. No difference from equations. The only difference is when you add or subtract, when you multiply or divide negative numbers, you must flip the direction of the sign. It's just the way it works. Okay, you just need to memorize that. Do not forget to do that. If you don't do it, your answer is going to be completely wrong. So here I'm going to divide by negative 1. I'm going to divide by negative 1. I'm going to divide by negative 1. So I'm going to have x on the left. I'm going to have negative 10 on the right, because 10 divided by negative 1 is negative 10. But instead of the arrow going this way, I'm going to flip that arrow around and put it that way. Only then is the answer correct. X is less than or equal to negative 10. So on your number line, if this is negative 10, you know, the set of all numbers like that are going to be all these numbers like this. Just like that. And it's going to be including negative 10, so you're going to have that with a closed circle right there. I'm sorry. I've totally made a mistake here. Just forget about that. What you're going to have here is you're going to have a number line that looks like this, and you're going to have negative 10, and it's all numbers greater than negative 10, so it's going to be closed and it's going to be to the right. I apologize for that. It's going to look like that. So you put your number and it's going to be greater than, off to the right. And that's the answer. Okay? Okay, so the next kind of problem we're going to do is going to look a little bit simpler. And I'm going to go ahead and try to mix it up again. I wouldn't want you to get too accustomed to what I'm doing here. I'm going to go ahead and try to make it a little bit different and use a different color. So I've got, let's say, 2x. I don't really like the way that comes out. It doesn't show up as well. Let's say we have 2x minus 3 is less than or equal to 5. Okay. I want to get 2x by itself, so I'm going to move this 3 over here. So I'm going to add 3 to both sides. I'm going to be left with 2x is less than or equal to 5 plus 3. So carrying this down, 2x is less than or equal to 5 plus 3 is 8. Okay? And in order to get x by itself, I'm simply going to divide both sides by 2. So x less than or equal 8 divided by 2 is 4. I did not flip the order of this sign because I did not multiply or divide by a negative number. And on your number line, that's going to look like, if this is 4, 0 is over here and 4 is over here, then I'm going to have a closed circle because it's less than or equal to, and that's going to be all these numbers off to the left, less than or equal to 4. So we're talking, you know, 3, 2, 1, 0, negative 1, negative 2, negative 3, on to negative infinity. So notice for inequalities, by and large, your answer is not going to be a number. Your answer is going to be a set of numbers. And that's just simply because inequalities are equations that kind of involve sets of numbers. So let's say we have 2x plus 9 is less than or equal to x plus 8. Okay? First I want to move this x over here, so I'm going to subtract x from both sides. 2x minus x plus 9 less than or equal to, x minus x is 0, so I'm not going to write it, and I have an 8 there. 2x minus x is simply x. Plus 9, got to carry that forward, less than or equal to 8. Just like this. Now I'm going to move this 9 over here. I'm going to subtract a 9 from both sides. I'm going to do the opposite of this addition in order to do that. So x, and 9 minus 9 is 0, so I'm not even going to write it, less than or equal to 8 minus 9. Here I've subtracted 9 from both sides. So then x is less than or equal to 8 minus 9 is negative 1. Okay? And then if you were to graph that on a number line, if you had negative 1, that would be the set of numbers to the left, which is less than that, and a solid dot, which means less than or equal to. So pretty much all the tricks that you've learned, you know, when dealing with your equations are going to be applicable here. Okay, let's say you have something that looks like 3 parentheses x minus 8 parentheses less than 5x plus 6. First thing I want to do, just like equations, I want to get rid of these parentheses. I want to distribute the 3 in like this. So 3 times x is simply 3x. 3 times negative 8 is negative 24. 8 times 3 is 24, and negative times positive gives me a negative. Carry my less than sign. I'm just going to rewrite the right-hand side of the equation. 5x plus 6. Okay. Now I'm going to go ahead and move this 24 over here, get the numbers on one side. So I'm going to add 24 to both sides. So I'm left with 3x on the left, minus 24 plus 24 gives me a 0, so I'm not even going to add it. I'm going to carry my sign down. 5x plus 6 plus 24, because remember I'm adding 24 to both sides. So I'm going to be left with 3x less than 5x, and then I just add these numbers, which is, 24 plus 6 is 30, just like that. And now I'm going to move my 5x over here, so I'm going to subtract 5x from both sides of the equation, because the opposite of this positive number is a negative, so I'm going to subtract. So I've got 3x minus 5x less than 30, because on the right 5x minus 5x is 0. So continuing, 3x minus 5x is negative 2x less than 30. Because the bigger number is negative, so it's going to be negative. 5 minus 3 is 2. And you've got to carry the x's through. Okay? And then the final thing is, I'm just going to continue this right there. The final thing is, in order to get x by itself, I need to divide both sides by negative 2, just like this. Okay? So on the left, these 2's are going to go away. Okay, which leaves me with x, and then 30 divided by 2 is 15, and because I have divided both sides by this should be a negative 2, by a negative number, I must flip the direction of this sign. So x is greater than 15. That is the answer, and of course if you were to graph that, if this were 15, you'd have an open circle, and it would be all the numbers out here to the right, greater than 15, but not including 15. Okay. Okay. Let's do one like this. Let's say we have x times 5x minus 5 greater than 5x squared plus 15. Just like that. First, let's distribute the x in. X times 5x is simply 5x squared, because x times x is x squared. The 5 just stays the same. Minus 5 times x is 5x. Greater than 5x squared plus 15. I just rewrite the right-hand side of the entire equation here. Notice I've got a 5x squared and a 5x squared. Those are going to go away. And it's the same reasoning as regular equations. It goes away because I can subtract 5x squared from both sides of this equation, and that means this one would go to 0 and then this one would go to 0. So they just drop out. So I'm left with negative 5x greater than 15. And in order to get x by itself, I've got to do the opposite of this multiplication, so I'm going to divide by negative 5, divide by negative 5, which means x is going to be less than negative 3. I flipped the sign around because I divided by this negative 5, and that's going to be the answer there. Okay? So it's really the same thing that you do with equations, so we're kind of blowing through this sort of fast because basically it's just a bunch of simple equations. You just don't have all the baggage associated with the equal sign. You've got something a little different. Let's move on to something a little more interesting a little bit different. Let's say you have something that looks like this. 2 less than x minus 5 less than 5. Now this looks a little different. I have 2 less than signs in my little box there. Okay, what does that mean? That means that whatever x is, x, when I subtract 5 from it, it's between, the answer here is going to be between 2 and 5, because the way you read this is from the inside out. This quantity is greater than 2 because I'm reading it this way, greater than 2 because the big part of the sign is facing me, so greater than 2. And also, the same thing in here is less than 5 because the pointed arrow is going here. So it's greater than 2, less than 5. So it's bounded between two numbers. Okay, but we want to make it a little bit more clear. So how can I do that? Well, I want to get x by itself. I've got 5 subtracted from it. The way you do that is you add 5. If you add 5 to the middle part, the 5 is going to go away. When you do this, you must add 5 to each part. You must add it to this side, and you must add it to this side. So I'm going to go ahead and do that now. I'm going to have 2 plus 5 over here. I'm going to keep my sign the same. In the middle, I'm just going to have x because negative 5 plus 5 is 0. I'm going to carry my sign through here, and I'm going to have a 5 plus 5. All I've done from step 1 to step 2 is add 5. Okay. On the left, I'm going to have 7. In the middle, I'm going to have x. And over here on the right, I'm going to have 10. So x is greater than 7, less than 10. So if I were to draw this on a graph, okay, if I had 7 here and I had 10 here, there'd be an open circle here, an open circle here, and the solution to this equation would be all the numbers between 7 and 10, not including 7 and not including 10. So 7.1, 7.2, 7.3, 7.4, and so on and so forth to 9.99999, but not including the two end numbers because there's no equal signs under here. So you really solve this in the same manner that you solve equations. It's just that it's a little different because you've got to add the numbers or subtract the numbers from 3 different places. So let's say we had, taking it a step further, 4 less than minus 2x, which is also less than 10. Okay. Now I want to get the x by itself in the middle, and the way I need to do that is divide by negative 2. Okay. However, when I divide by negative, all the signs are going to flip. So let's do that. I'm going to divide by negative 2 here. I'm going to divide by negative 2 here, and I'm going to divide by negative 2 here. On this side, I'm going to have 4 divided by negative 2 is negative 2. And because I've divided by a negative, I've got to flip this sign around. So I've flipped it around. In the middle, I'm simply going to have x because negative 2 over 2 is 1. So they go away. And I'm going to have to flip this sign for the same reason as before, like this. And 10 over minus 2 is minus 5. So now, x is less than minus 2, but greater than minus 5. And that's kind of confusing to understand until you draw it. If this is, let's say this is 0, and this is minus 2, and this is minus 5, because we're getting increasingly negative as we go this way, then I have an empty circle here and an empty circle here, and this will be the set of numbers between. X will be less than negative 2, less than negative 2, but greater than negative 5, greater than negative 5. So it's the set of numbers between there. Those numbers are the only numbers that satisfy that inequality. And we had to flip both signs because we divided both sides of everything by that negative number, and that is what caused us to have to flip the signs around. It's one of those rules of algebra you're just going to need to memorize. One of the few that I actually say, just go ahead and memorize it. It makes life a little bit easier. What if we had negative 3 less than or equal to x over 2, which is less than or equal to 5? Well, how do I get x by itself? I'm going to multiply all quantities by 2. If I multiply by 2, the 2's are going to drop out in the middle, and then I'm going to just end up with what I end up with on the ends. So, negative 3 times 2 less than or equal to, in the middle I'm simply going to have x, because I would have a 2 out here, and the 2's would cancel. Carry my sign there, and then I'll have a 5 times 2. So negative 3 times 2 is negative 6, less than or equal to x, which is less than or equal to 5 times 2 is 10. And that is the answer. And if you graph that, if 10 is way over here, here's 0, and here's negative 6, you are less than or equal to 10, but greater than or equal to negative 6, so it's going to be all these numbers in between. Okay. I have 2 more problems, and we're going to call this section done. What if I have 3 less than or equal to 2x minus 1 less than 5? I want to get the x by itself. First step is I got to get rid of the 1. I'm going to add 1 to everywhere because I'm doing the opposite of the subtraction. That's going to get rid of 1 for me. So 3 plus 1 less than or equal to 2x. The 1 is going to disappear when I do this. Less than 5 plus 1. 3 plus 1 is 4. Less than or equal to 2x less than 6. Now I'm going to divide by 2 to get rid of this 2 because it's being multiplied. Divide by 2, divide by 2, divide by 2. This goes away. That's the whole reason we're doing it. 4 divided by 2 is 2, less than or equal to x, less than 6 divided by 2 is 3. And that's going to be the answer. Now this is kind of an interesting graph. If you graph it, I've got, let's say 0 is here, 2 is here, and let's just say 3 is here. That's not to scale, but let's just say x is greater than or equal to 2, so I've got a closed circle because I'm also equal to 2, but less than 3. I've got an open circle here. So if I graph it, it would look something like that. It's closed at the 2 but open at the 3 because it's greater than or equal to 2 but only less than 3. So 3 itself is not included in the solution. Okay. Okay, now we'll just have one more problem on the topic of solving inequalities, and then we'll just call this section quits. And this is kind of a neat problem. Let's say we have x squared plus 3 less than or equal to x parentheses x minus 3 close parentheses less than or equal to x squared plus 9. Okay, so let's go ahead and work on this middle part here. This distributive thing going on here. Let's just copy this down. X squared plus 3 less than or equal to, now let's work on the middle. X times x is x squared minus x times 3 is 3x. Because negative 3 times positive x is going to be negative 3x, so I've got to put the negative there. Carry the sign, and let's just repeat the problem over here. X squared plus 9. Okay? Now, interesting thing. Notice I have an x squared here, I have an x squared here, and I have an x squared here. I have x squareds common everywhere. That means that they are simply going to go away. They don't exist. How can I do this just so confidently? Because if I subtract x squared from here, and subtract x squared from here, and subtract x squared from here, they all go to 0. Anytime you have something common everywhere, across the equal signs or across the inequalities, the term, and it's exactly the same with the same coefficients and everything's the same, they just drop out. So I'm left with 3 less than or equal to negative 3x less than or equal to 9. Now how do I finish this guy off? Well, I got to get x by itself, so I'm going to divide by negative 3 because I'm going to cancel this multiplication out. Divide by negative 3, divide by negative 3, divide by negative 3. On the left, I'm going to be left with negative 1. 3 divided by 3 is 1, and then negative and positive give you a negative there. And I'm going to switch the sign around because I've divided by a negative. These two cancel out, so I only have an x in the middle. That's why I did this in the first place. 9 divided by negative 3 gives me negative 3, and I must switch the sign around because I have divided by a negative number. So this is the answer, and if I were to graph this, if I had negative 1 and the negative 3, here's 0 over here for reference, I'd have a closed circle here and a closed circle here, and x would then be everything in the middle because I have equal signs under here. So it's greater than, correction, it's less than negative 1 because you read this way, x is less than or equal to negative 1, x is greater than or equal to negative 3. That's what the graph looks like. That's going to about do it for solving inequalities. And that's actually going to do it for part 2 of the course. We have introduced equations, we've done simplification of terms, we've kind of learned some things about inequalities. So that's going to do it about part 2. And the next major section of the course is going to be on polynomials, and then we're going to start getting into some more complicated looking algebraic expressions. So that'll about do it for this section of the course.